So in the last two slides, I've set the context that we will be discussing about an online retail shop, that is shop sphere, right? And I also discussed the key terms. So we are now entering first layer of the staircase, the AI staircase, right? That is data. So everything starts here. Okay. So no data, no analytics, no AI, no data science, nothing. So think of data like a crude oil, right? So crude oil by itself has very limited value, but after refining, it becomes fuel. People extract plastics, chemicals, and thousands of useful products, right? Similar to that, data is also raw, cannot be used for more value, but if you refine it, then you can generate huge value for the business, right? So let's start. So let's simplify data even further, right? So let's say when you see some information like, today's, temperature is 28 degrees centigrade. Suppose if patient's blood pressure is 120 by 80 or something, right? And the speed of the car is and so on. So data is nothing but a recorded fact, right? So all these examples, so dollar sale at Apple OS is $2,500. So all this recorded fact is nothing but data, right? So these are all facts, but facts alone, don't create any value. But context creates value. Please understand this one because I see a lot of students or career switchers, face difficulties in this area, business acumen. So you need to connect the data to the business context and try to understand the information, the fact, and come up with some insights. Let's take a simple example here. So there is a person who clicked item number 4821, some random item number, let's say. Some user clicked. And also we captured this guy browsed sneakers 3 times a day. He didn't make any purchase, but he was simply browsing. So he clicked one item and he browsed 2, 3 times a day. So what is the extraction? What insight that we get? That means his intent is there, but he is not able to complete the purchase. Maybe he is expecting some discount, right? So that is insight. So suppose if the user is likely to buy, if shown a discount is what actually the insight that if you're extracting from the information from the raw data. So raw data alone cannot generate value, wherein you bring the context, add some more information, then there are insights. So this transformation from data to information to insight is exactly what businesses are about. So that is why data is very important. Okay, so now let's see about the different types of data. So basically, or maybe shape or type, whatever it is. It's structured data, unstructured data, and semi-structured data. So, like for example, in this retail example that we're going through, let's say if you're capturing consumer ID, right, and the item that the consumer has purchased, product SKU ID, and the price tag, right, and also set time. If these sort of information, if you're capturing and storing this in the form of rows and columns, that is called as structure, right? SQL is one of the popular database. Similarly, you can actually, you would have seen Excel files, etc. So this is structured data. Now, semi-structured, right? So this is partially organized. This is completely organized. For example, in Python, there is a data type called dictionary, right? Suppose if your file is stored in data or dictionary format, then set or dictionary format, then that is a semi-structured, right? So wherein you have to bring it to the no organized form or normal form to apply analysis, right? JSON file is one example, file format. Similarly, XMLs and some log files, right? So software development log files or any log files for that sake, right? So you see here, so product catalog, consistent key. So the catalog ID is a number, but description is not a number. So it's a semi-structured. I hope you are clear on these two things, right? The third one is unstructured. There is no predefined format. It could be text, image, videos, PDF files. I mean, you use PDF files, suppose if you want to build a RAG system to extract that information and summarize and to respond to the user prompt, right? So those cases you use different unstructured data shapes, right? So these are the three key things you have to understand, right? Now let's move on to the next topic. So we understand how data is important and why it is important. Now we also discussed the different formats or different types of data. Now let's see where actually this data comes from. And most of us we think that data the companies collect data only from websites. Yes, that is true. So if it is a portal, if there is a portal, could be bank or e-commerce, right? So customers visit the portal or website and then click something, they search something. So this information is it's called as clickstream when they actually visited the page, what sort of area of the page they browsed, they spend more time, etc. This information is captured through website. But beyond that, for example, if it is a bank or online retail, the transaction data is captured through point of sale machines. Right? Suppose if you are shopping, you swipe your card, right? Immediately that information is captured through POS. And if you're paying, that is also captured through different transaction systems or machines. So this is the core thing because this involves numbers, right? Dollars, how much money the customer is giving it to me, and how much they are spending for different marketing activities, etc. This is a transaction data. So in pharma or banking, mostly third party sources are there like claims data. So which patient actually applied claim, how much amount actually they got as a claim, etc. So that is a different story. But transaction, whenever for banking or retail, e-tail, etc., that is through completely the POS. Right. Then the next part is the sensors and IoT. A simple example is, even in today's colleges or organizations, every time people to enter. Like few years back, people manually or physically used to call out the names and take the attendance. But now it is simply a swipe card, right? It's a Internet of Things. The moment you swipe your card, it captures your attendance and it gets stored into the database. So that is sensors. Similarly, there are so many things, right? Sensors and IoT devices these days, they captures the data. Then third-party APIs, so for example, there is a company, they collect some information, that information is stored somewhere. And if you want to acquire that information for your analytics purpose, that you can actually extract that information through a API call, right? So could be weather data, social signals, or competitor pricing feeds. Especially this is important application protocol interface. APIs is this data is stored on someone else's server, wherein you through internet access that information for your analytical purpose. Right? So you procure it, you pay something and procure it. That is actually third-party APIs. Even for your ChatGPT, if you want to build some GPT-based application, you have to bring tokens, right? So through a API call. Then the last one is documents. So these days, everything is documented, right? Because of the data compliance, data governance reasons, they have to document everything, like whatever the contract between two people, two companies, and policies, product manuals, everything. So everything comes under document. So like this, so many sources with data gets generated. Now you understand what are the different shapes of the data and then where data comes from, right? Okay, let's return to ShopSpear. Okay, what exactly does ShopSpear collect every day, right? So clickstream events. So this is the important thing. You hear this word, frequently, especially in online businesses. So what is clickstream basically? So the moment the user or consumer visit your website, whatever action that consumer is doing, that is captured through these clickstreams. It's called as clickstream. Okay. So imagine like millions of, we discussed about, right? What is the volume of user base for this company? Millions of events happens, like the person is coming and hovering on a particular product for some time and he's adding to the cart, he or she search something, and he saved the cart, and so these sort of things stored in a JSON file, right? It's unstructured. And if suppose if he left some comment, right? Or this is actually customer reviews, some reviews once he purchased the product, and whenever or during the purchase, what sort of item he purchased, what is the quantity, what is the price. So everything is order records, and then after that the reviews, customer reviews, then the product related information. It could be photos that the company upload so that the consumer will go through it. So that is also a data, because every time when you are placing one product in your portal, right? So you have to have the catalog, the information, the images and everything. So this is bit of unstructured and all images and stuff like that. So just relate this example to any other industry, could be banking or pharma, and think of like what sort of data that those industries collect and store, right? So now you just spend 1 minute here. Let's spend 1 minute. So clickstream events, what it tells basically, we can understand on average what is the time that they are spending, on which product they are spending more time, and where actually they are not able to complete the purchase, what is the reason. So to analyze and to deep dive, to enhance your product value, you can actually leverage this clickstream events. This will tell us what is the order value, how can I optimize my order value. I can roll out some campaigns, or I can give some discounts, right? If he's a more loyal consumer. The reviews, the NLP part comes here, the text part here. So we can read the reviews and see if there is any user who is not happy with the product or service, right? So that is customer reviews. And this one, if they comment saying that the product photos or images are not good and catalog is not having detailed information, then we can optimize the part. So each and everything, whatever the organization, the firm that Shopspeare collects and stores, there is a need. You can actually analyze it and come up with some useful or meaningful insights for your business. So this is a raw data inventory. Now, I mentioned a few minutes ago when we were in couple, I think second slide, right? I think the how data collects. Now we understand what are the different type of data, like, and different inventory, right? Could be clickstream, order records, etc. Now, how this gets captured, this gets extracted and stored, right? So primarily in any industry, people people collect the data in two ways. One is the batch processing, and the other one is streaming. This is very, very important. Okay, so batch is like receiving yesterday's newspaper, right? So you get a summary of everything has happened. That is batch. Because if the organization has no privilege to connect to live and collect the data, live streaming, then they do batch processing. For example, today, let's say, um, so 2nd June 2026, for example, right? So this day they collect what is the consumer information, orders information, everything, and then they process it, then they upload into the main server. This is batch. Wherein streaming is basically it's in real time. Streaming is the moment user enters into the website and do some action, immediately that information extracted and stored into the database. Okay, hope you clear with these things, right? So especially when it is a sales or revenue, these kind of information or these kind of things or weekly performance, they do on batches, monthly, quarterly, weekly, daily, hourly, right? It's a batch processing. Wherein streaming is, it happens in real time. Example, let's say fraud detection, right? Suppose if some unusual activity happened, if you ever notice, if you are logging into your Gmail from a different personal computer, right, someone else's computer or some other machine, immediately it will ask for you to authenticate it, right? So those sort of things are called as real time. So it is capturing your information real time. Okay, live recommendations based on your behavior. Immediately you get some recommendations. Um, GPS tracking is also streaming live or streaming data or live data, right? So that is about two ways of collecting the data, right? Some organizations, they do both, right? So they do batch processing for few like order records or some sort of information like click streams. But click stream is of course it is live. But yeah, for some consumer purchases, etc., they may do batch to based on their data space, server space, etc. Right? So and one important thing here, if anyone wants to become a data engineer or a data engineering expert, right, these are the popular tools at tech stack. You can actually explore and learn. Apache Spark, DBT, SQL. So these are the tools which helps in processing the data for batch. Similarly, for streaming, Kafka, Flink, Spark Streaming. These are the tools which helps you to connect to the system and extract the data real time. Okay, so that's about the collection or extraction of the data using either batch or stream. Now, this is very important. Okay, so why data engineering or data processing? I'm sorry, not data engineering. Data processing is important while collecting because quality, right? So someone said like this, right? Garbage in, garbage out, garbage out. So a lot of times when you hear this word, a lot of times, especially in chat GPTs, right? People use this saying the garbage in, garbage out. What do you mean by garbage in, garbage out? If your data is not in quality, if you feed that data, if you apply your AI or machine learning or deep learning or anything, what output you will get? Obviously, garbage. No use for the business. So that's why quality, data quality is very, very important. So what do you mean by quality for the data, right? Well, first you need to check the accuracy. So is the information correct, right? So then the completeness. So are important values missing? What do you mean by completeness? For example, let's say there was a transaction happened yesterday by a consumer ID 11, right? So if that information is captured, consumer ID is 11 and dollar amount is 0, for example, and item blank and timestamp blank. So if you have this information, how do you know that what sort of value that this customer is giving, what sort of strategy I can build based on this customer's information? Nothing, right? So completeness is important. If something is missing, you have to make sure that you get the data from your raw source and make sure the data is complete. So accuracy and completeness. And then the next one is consistency. So what do you mean by consistency? Does the same customer appear the same way everywhere? For example, if you see like customer one and same information is repeatedly capturing, right? So something is happening, data is not getting refreshed. So that is actually consistency. So you have to make sure that there are no duplicates, right? Same row is repeating multiple times. That is very, very important. So of course, that's also called as uniqueness, but consistency is suppose if you see the customer information is missing, let's say last 3 months, the information is there, but current month it is missing, something is missing. He's active customer, but some information is missing. So you have to make sure that you're capturing that. Then the timely analysis is the data refresh enough to act on. Is data is getting refreshed or fresh? Suppose if you want to run a model, right, you make sure that you have enough data. You should not run 2024 years data to build something for 2027, right? So you have to have the timeliness as well. Validity. So this is important, right? Validity means what? So the format and rules. For example, there is a column called age. So age could be either male or female or prefer not to say. So I'm sorry, my apologies. Gender. So gender male, female or preferred not to say. So if suppose if this is not actually MF or something else, it says that 125, 225, some numbers. So this is not a valid information. Similarly, if there is a column called age, so age should be 18 to some 99 or 100. But if you see something like 250, which is not a valid number. So this is validity. A data engineer or data analyst, do some validations before they do analysis. But before that, while storing the data itself, the data modeler should make sure that the data they're storing is valid. Okay. And then uniqueness, this we discussed. Consistency and unique quite similar, but consistency is to make sure that the volume is consistent across the days. If suddenly if there is a decrease or increase, there's something is missing. Uniqueness is, suppose if there are any duplicates, one customer with three IDs looks like, three people. That is wrong. Actually, it's only one person, right? So you have to make sure that data is unique. Okay. So these are the top key six dimensions for data quality: accuracy, completeness, consistency, timeliness, validity, and uniqueness. I'll give one simple example. If you want to understand the top 10 customers whom if you want to give a discount, let's say, okay, it's a marketing campaign. Let's imagine you are using 2025 June data, right? That is not correct, right? So 2025 June data, how come it will help you to identify who are the top customers? They definitely made some, more transactions during July 2026. So timeliness. The second is the accurate information, and then the consistency, uniqueness. So all these things for predictive modeling or for reporting, for simple analysis, for everything, you have to make sure that the data is in quality and following these six dimensions, right? The bad data. So what do you mean by bad data? Any data which is, missing either of the dimensions that we just discussed, those six dimensions. It is not complete, it is not consistent, it is not unique, and it is not fresh, right? So if any data which is actually missing either of those dimensions, it is called as bad data. Now, what is the cost of bad data? This is important. So cost of bad data is, what do you mean by that? If you use that bad data and build something, whatever strategy you build, it will, no way helping your business. It won't generate any value, right? So many companies assumes that AI failed because the model was wrong. But often model is perfectly fine. The data is the problem. This is very, very important. So first thing is the problem. After the problem validation, if you think AI is the best to solve this problem, then the important thing is data. If you are not focused on data, directly jump to the model and don't complain on AI. It's about the data, right? Imagine one customer, appears as three different people in three different systems. Let's say in click streams system, orders, and then customer reviews. Imagine three different databases you have, and the same customer is appearing as three different based on some duplicates, right? Now, whatever recommendation engine that you built, that model will get confused, right? So that customer won't get any appropriate recommendation. So instead of understanding one loyal customers, it sees the incomplete customers. The recommendations become poor. The sales may go down. So engineers spend weeks in investigating. Eventually, they discover the problem wasn't AI. It was data quality. So this is why experienced AI team always investigates the data first, right? So spend good time or enough time on data. Make sure the data is in quality. Then start building the algorithm, AI algorithm, right? So that's about cost of data. So the last part in data. So we have some key things, right? You hear these things in on a day-to-day basis, especially when you are dealing the data like metadata, schemas, and data contracts, right? So metadata is about data. For example, let's say you have built a database. You collected some information about customers, right? It could be ID, clickstream information, or order records, etc. So, who created this table, right? When was it updated? When was it updated? And what does this table or this column mean? So, that is actually metadata. The schemas basically, right? This is metadata. It tells about the data set or database. Then the schemas is it defines the structure, right? So, for example, price, you have a column called price. So it should be numeric, right? So date must follow a specific format like YYDD. So different formats. I'll show you, when we discuss some examples, when we do analytics, I'll show you those different formats are there. So every column in the table, let's say there are 10 columns, each and every column has a structure, whether it is a numeric, whether it is a categorical or character or a text or date, etc. Right? Customer ID. So customer ID should not be empty. Right? Whenever you capture something about a customer, that ID should not be empty. So similarly, if you have a text, right? So it should be uh, words, characters. So some decimal numbers are there, some float. Like that, each and every column, has a structure that is defined in schemas. It's called schema, right? Then the last one, data contracts. So data contracts is basically the agreements between teams. So think of one team produces data, right? So another team consumes it. So both agree on the format and rules. For example, let's say there is a data team. So data team they build the pipeline to collect the data. And then analytics team, they actually start consuming it. So they have to put this contract, formal agreement saying that, okay, what is the purpose and what sort of rules that you are applying, what schema that you are using. That is actually contract. On top of all these, very, very important thing, governance. Governance. There is this GDPR. So GDPR compliance, you can explore about this. GDPR compliance is set of rules set by the governments, feds, to make sure that when you are collecting the information about consumers, their personal information, how you are using this or utilizing this data for your marketing purpose, and how secured, how you are actually securing your data. That's where your cybersecurity also comes, right? So this data storing, securing, and then utilization, everything you have to follow through GDPR compliance. This is personal information protection and governance. So if you want to become a data modeler or a person who actually collects the data and store it somewhere, okay, this is data modeling part, not machine learning model. So this is data model. Please don't get confused. So you can learn Kafka, Stream, these sort of tools. On top of it, make sure you understand these policies so that you do apply certain rules before you make it available for other teams to consume it. Okay, so this is the first layer, the data layer. So far, whatever we discussed is about data. Now you know how organizations collects the data, what are the different types, different ways to collect, and the different ways to store it, and what are the key things to make sure that the data is, in quality, right? Now let's move to the second layer, data engineering.